Today, the topic that we'll cover is uncertainties. Up till now, we are done with significant figures, and that was the first topic in measurement. The second topic is uncertainties. Now, first of all, how many types of uncertainties are there in our syllabus? In our syllabus, we'll deal with two types of uncertainties. One of them is systematic uncertainty. So the first type of uncertainty is called systematic uncertainty, and the second type of uncertainty is called random uncertainty. So these are two types of uncertainties in a given measurement. Now, what is meant by a systematic uncertainty and a random uncertainty? So by definition, one thing should be clear. These types of uncertainties will be studied with respect to the data trends. So when you achieve a data, the data trend will tell you that what kind of uncertainties you have. If your data trend is not according to certain expectations, then you have some uncertainty. And systematic uncertainty will change the data in a certain way, while random uncertainty will change the data in a certain way. Now, first of all, what is meant by random uncertainty? Random uncertainty is basically it it generates fluctuations in the so random uncertainty will generate fluctuations in the given data. It generates fluctuations in the given data. One thing, if you repeat the same reading, again and again, then you will get a different. So if you repeat the same value, if you repeat the same reading again and again, then you will get a different value for the random uncertainty. And one thing, a random uncertainty will sometimes result in a reading that is more than the actual value, and sometimes it will result in a value that is less than the actual value. So the sign of uncertainty, will also fluctuate. Sometimes it will be positive and sometimes it will be negative. So basically, a random uncertainty has a random behavior. If the reading is repeated, it changes its value every time, and its sign is not fixed. Sometimes it is positive, and some other times it will be a negative uncertainty. Now, what is meant by a positive uncertainty and a negative uncertainty? A positive uncertainty is basically, what is a positive uncertainty? An uncertainty will be positive if an uncertainty will be positive if the reading is greater than the expected, or you can say actual value. So when you get a situation in which the reading is more than the expected or actual value, the uncertainty is called a positive uncertainty. And what is meant by a negative uncertainty? A negative uncertainty is the one when if the if the reading is less than the expected or actual value. So if you get a situation in which the reading is less than the expected or actual value, then the uncertainty is called a negative uncertainty. Now, before moving on, you must know that what is an actual value. Basically, actual value is the value found by the human beings by the using the most accurate methods available. So no value of any quantity is given by God to humanity. That's why we cannot claim for any value to be authentic or exact or 100% accurate. All the values are calculated by the human beings using experiments. So they are the expected values or they are the accepted values. So the most accepted value by any culture of humanity is called the actual value. So right now, the values of quantities that we accept, they are the actual values. Actually, they are the most accepted values. Just for example, if someone asks you, what is charge of an electron? Then we assume it to be 1.6 into 10 power minus 19 coulomb. And we say that this is the actual value of the charge. we say that this is the actual value of the charge. Now, why is this an actual value of the charge? So basically, the most accepted value of charge is 1.6 into 10 power minus 19 coulombs. So this is the most accepted value of charge on an electron. This value is not given by the God, it is calculated by experimenters, and it is the average of most number of the experiments. That's why we say that this is the actual value. However, since it is calculated by human beings, so chances of error are there, but it is the most agreed upon value. So we can say that 1.6 into 10 power minus 19 coulombs is an accepted value of charge on an electron. So 1.6 into 10 power minus 19 coulombs is the accepted value of charge on one electron. In the same manner, when we say smaller g is 9.81 meter per second square, it is the most accepted value. So since it is the most accepted value, so we say that actual value of g is equal to 9.81 meter per second square. So in general context, actual value of a quantity is generally the value that is common and most accepted, or sometimes it is the value calculated by the most accurate experiment with the most accurate method. So the best possible value of any quantity is called the actual value of that quantity. Now, sometimes we perform experiments in which the actual values are there, and you know that, and experimenter knows the actual values. However, in some other experiments, the actual value could be missing. So in some experiments, the experimenter, the experimenter knows the actual value, while in some other experiments, the actual value could be missing. So there are some experiments in which the experimenter knows the actual value, and in some other experiments, the actual value could be missing. For example, you perform an experiment to calculate G, and experiment is performed to calculate smaller g. So if you perform an experiment to find smaller g, then actual value of g would be 9.81 meter per second square. Now another example could be someone performs an experiment and experiment is performed to find height of a random person. Now in this experiment, you do not have any actual value. The answer could be anything, and you do not have any initial data. Now in this, however, you know a possible range of the answer. The possible range of answer is already there, but if you say the actual value or some expected value, you cannot have that. It's a random person. So in this experiment, the actual or the expected value, is missing. So this is the experiment in which the actual value is missing. And one thing, whenever you perform experiments, you never take a single value to make conclusions. You always go with a graph. So the principle of performing experiments is that whenever we perform an experiment, we take several readings to plot a graph. So whenever you have to perform an experiment to investigate something, you take several readings and then you plot a graph instead of just taking one reading. The reason for plotting a graph is basically, so we'll say that plotting a graph is better. Plotting a graph is better than taking a single reading plotting a graph is better than taking a single reading, as number one, a single reading could be an outlier or it could be anomalous. Now, if you do not have many readings, then a single reading, even if it is outlier or it is anomalous, it may be away from the actual result. You could have you could have made an error that you do not know. So when you take a single reading, you do not have other readings or comparison. That's why the nature of the readings cannot be determined. You cannot make a comparison. So how this problem is solved? While plotting a graph, when you take 6 to 7, when you take 6 to 7 readings, when you take 6 to 7 readings to plot a graph, then so when you take 6 to 7 readings to plot a graph, then the anomalous reading, that is also called outlier, is identified due to its comparison with the data trend of the other readings. Basically, the data trend, when we take multiple readings and plot a graph, then the data trend will help us to eliminate or to identify the readings which are away from the expected trend, and those readings are outliers and they are left. So basically what we are saying is that if you take just one reading and if you take multiple readings, what is the difference? Now if you take just one reading, you cannot predict, with this one reading you cannot predict the quality of the reading. Just for example, if you take just one reading, then quality of this data point cannot be determined. There is no way to determine the quality of this data point if the actual value is not there. So if you take only one reading, then you cannot determine the quality of that reading. However, when you take multiple readings, like 6 to 7 readings, let's suppose you take 6 readings and you see the trend is like this. Now you see the 5 data points are in a line, while one of them is away. So by taking multiple readings, you are able to identify an outlier point. So that is the advantage of taking multiple readings and plotting a graph. One other example could be, let's suppose you perform an experiment in which you take some readings and the readings were, your readings were like this. However, you get one reading which was here. Now, by observing the data trend, you can see that this is the reading that is outlier or anomalous. Identifying this anomalous point in which you have made a huge amount of error is only possible by comparing it with the data trend of the other readings. All these data points are making a trend, so they are acceptable. This point should be eliminated. So by taking more readings and plotting a graph, first of all, you are able to identify an outlier data point or an anomalous data point. Now, what is the second advantage of plotting a graph? The second advantage of plotting a graph is that When you draw a best fit line, you can eliminate the fluctuations or the random error. So the effect, random errors basically make the data to fluctuate. So the the effects of basically by plotting a line of best fit. This was your practice in your O level. When you are given with some data points, you always plot a line of best fit. That is the average of the data points. So by plotting a line of best fit, the effects of random errors, the effects of random errors can be eliminated. If you take a single reading, the effect of random error may cause fluctuation and your result could be incorrect. However, when you plot a graph like this, when you plot a graph, then by plotting a line of best fit, that is the average of your data points, you can eliminate the effect of the random error. So if you draw a line of best fit, then the effect of random error or fluctuation can be eliminated, and this is only possible when you plot a graph. Now, the first type of error that we studied is a random error. Now let's see what is a systematic error. A systematic error is the one, an error that shifts the average of data points. So systematic error is basically an error that shifts the average of data points away from the actual value. Now, one thing, it shifts the data. It shifts the data in one direction. And if in an experiment the actual value is missing, then you cannot predict the systematic error. So if you find a situation in which if the actual value is missing in an experiment, then the systematic error will be unpredictable. So systematic error will only be predictable if you have actual value in the experiment. So if you find a situation in which the actual value is missing, then the systematic error will not be predictable. Now let's make a comparison between a systematic error and a random error. Let's suppose if we compare the points of systematic. Let's compare systematic error with random error. First point, it shifts the data away from the actual value. Basically, average is shifted. So it results in shifting of average of the data. So systematic error always shifts the average of the data away from the actual value. What about a random error? It generates fluctuations. It generates fluctuations in the data points, and it has no effect on the average of the data. Second point, it only has one sign. It is either positive or negative. It is either positive or it is negative permanently. So it will not change its sign. A systematic error, if it is positive, it will remain positive. And if it is negative, it will remain negative. It will not change its sign. The random error, it can be both positive or negative. Both possibilities are there. A random error could be positive or it could be negative. Both possibilities are there. Now today we have to today our lecture is up to this point. From tomorrow we will continue from this point onwards. Take care, students.